Hi, boys and girls. This is Mrs. Roach here for our next lesson in science. And so before we get started, I just want to make sure you're ready for learning, okay? So that you have a quiet space, you have a pencil, and you have a notebook to write in. So let's get started. We are going to move on to lesson 2 in the solar system called Patterns of the Moon. We're going to be learning about the moon this week. Our essential question for lesson 2 is what causes the repeating pattern of the moon's appearance? And so we're going to be able to answer this question at the end of the lesson with what we've learned. So we will return back to this question. All right, today's objectives. I'm going to move my screen, place myself on the moon. I can explain the repeating patterns of the appearance of the moon by studying its movements. And I can describe the role of a selenographer and how it relates to the moon. All right, so we are going to get ready for learning. And we're going to start, boys and girls, with our Page-Keeley probe for lesson 2. So I'm going to pull that up so you can see that nice and clear. All right. And so, boys and girls, you've likely noticed that the moon, it appears in different shapes at night. So sometimes it looks like a full circle. Other times it may look like a half circle or a crescent shape. And so there are patterns in the way that the moon appears when we see it. So what kind of things can we predict using these patterns? Okay, so I'm going to read our Page-Keeley probe, and I want you to think about that. Our Page-Keeley probe is called Patterns of the Moon. And it says there are regular repeating patterns of the moon that can be predicted. Put an X in any of the boxes that are examples of things that can be predicted by regular patterns of the moon. And so for right now, I just want you to listen to me read each box aloud. And you're not going to do anything yet with this activity until the next slide. So just listen for right now. So the first column here, we have seasons, solar eclipses, the length of shadows, position of the moon in the sky, length of a day, tides, direction of shadows, sunset, lunar eclipses, moon phases, sunrise, and weather. So, you are going to explain your thinking and how did you decide which things could be predicted by regular patterns of the moon? Okay, so here is our Page-Keeley probe again. I would like for you to do now is reread each box. And we can't put an X in the boxes because we don't have our Be a Scientist notebooks. But what you can do is write down the word or phrases of the things that can be predicted by regular patterns of the moon in your copybook. So you're going to pause and do that now. And you're going to explain your thinking. How did you decide which things could be predicted by regular patterns of the moon? So try your best to explain your thinking in your notebook. Okay, pause now and please complete this activity. Okay, so I hope you were able to complete that activity in your copybook. One of the boxes or phrases I would have written down as my prediction is moon phases. So if you look up here, boys and girls, moon phases. And the reason why I'm predicting that this is a thing that can be predicted by regular patterns of the moon is because I notice at night that the moon does not always look the same. So I'm thinking that it follows some sort of pattern, okay? So you may have also written down moon phases as well as some other things in some other boxes. And so we're going to return to the Page-Keeley at the end of lesson 2, and we'll either add some things to our thinking or adjust our thinking if we've learned something new, okay? So we will return to this later on so you can check your answers. All right, here is our Science in the World connection, okay? And so take a look at these photos of the moon during the day on the left side and during the night. And yes, you can sometimes see the moon during the day, and some of you may have actually noticed that before. So what questions do you have about the moon and its phases? You're going to record these questions on the next slide when I say to pause. But for right now, just take a look and see what do you notice about the moon? What do you wonder about what you see in these photos? What interests you about the moon in these photos? So please just observe. And we are going to go to the next slide. And I'm going to give you a chance to write down any questions in your notebook. And so please pause and do that. If you need to go back to the previous slide and look at the photos again, you may. So please pause and do this activity. Okay. So here is a question that you may have come up with. Why do we see different parts of the moon at different times? And so we're going to be able to answer this question at the end of the lesson with what we've learned. And you may have come up with some different questions. So please feel free to reach out and, through Google Classroom and ask your teacher if you came up with some different questions. All right. All right, boys and girls, we're going to talk about our career connection for lesson 2. And our career connection is a selenographer. And a selenographer gathers information and data about Earth's moon to create an accurate map of the rocky surface. With these maps, future moon missions can successfully navigate the terrain. So boys and girls, a selenographer basically takes the data that has been collected, and we're going to talk about how that data is collected next. And they take that data and they create maps for future missions. And so not we, but NASA is planning the next mission to the moon. And so I'd like you to just watch this video clip about NASA's exploration to the moon and how they're planning for the next exploration. And think about how a selenographer would help this process, okay?
Ignition sequence start. All engines are.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man.
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of the giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this call. We are NASA. And after 60 years, we're just getting started.
Okay, boys and girls. So you just watched a video clip on the next mission to NASA. And so, boys and girls, along with space engineers, selenographers are they're like computer programmers. And so they analyze data and they use that data to make a map of the moon. And so you're probably thinking, Well, where does this data come from? How do they collect it? And so what you're going to do now is you're going to read the selenographer's journal entry that's taken from our Be a Scientist notebook. You're going to learn a little bit more about what a selenographer might do, okay? And then we're going to answer some questions together after you've read. So please pause now and read the journal entry to yourself. Okay, so let's answer some questions based off what we've read. First question says, why is an accurate map of the moon important for moon missions? So let's look back in the text because we know we can find our answer in the text, okay? And so if you look at this first paragraph here, okay, and the last sentence, it says, our goal is to have a complete and accurate map of the moon's surface in order to prepare for future crewed missions to our nearest neighbor in space, which is the moon. And so there you have it, boys and girls, our answer to the first question of why is an accurate map of the moon important? Well, we just found an accurate map allows crew members on a moon mission to navigate the moon's surface easily and to find valuable resources such as ice. And so, boys and girls, we also learned that water can be found in the form of ice on the moon, okay? And so they could use that for drinking, washing, and cooking. And I also thought it was interesting, the last sentence, it says that it also can be used for rocket fuel and to make breathable air. So I thought that was pretty interesting. All right, let's take a look at our next question. How does a selenographer make accurate maps? Let's go back in the text and find that answer. And so again, if I look here in this first paragraph, okay, the second or third sentence, I analyze data from various lunar orbiter and rover missions. And so, boys and girls, we learned about rovers last week, okay? And so that is how they get their data. Selenographers use data from previous missions and images from rovers and also satellites to make maps of the moon. And so, boys and girls, what they do is for this next mission that they're planning, they will design a map that the astronauts can do their next mission with. All right. Here is our essential question, boys and girls, and we will return to this next week when we continue learning about the moon. But it says, what causes the repeating pattern of the moon's appearance? So I want you to think about that essential question until next week. And so we're going to close out with some closing thoughts and questions.